we normally find, especially when it comes to home wiring, or what we refer to as my top boss as a domestic electrical installation. Now, there are a lot of issues that you may encounter, especially when we talk about electrical installation. Now, in a layman's language, we talk about wiring. First of all, thank you so much for joining me in this live stream. If you'll be watching this video in a recorded version, Top Boss, thank you so much for your support from day one. They are talking about this important aspect when it comes to electrical installation, which is definitely wiring. My top boss. Today, I want us to be very interactive in this live stream. It's been a moment since I was in this stream. Now, on my board here, I have a consumer unit. I have an installation which is definitely what we refer to as a ring circuit for socket wiring. We also have a radio circuit for socket wiring, which is coming from the consumer unit going to this socket. But what is the major distinction when it comes to ring circuit as well as radio circuit? Simply for radio, it starts from the consumer unit, goes to the first socket, and then it is connected to the second socket, and then finally the third socket, and that's it. That is the end of that circuit. Now, when we talk about a ring circuit, my top boss, just as the name suggests, it is a ring. How? It starts from somewhere and ends somewhere. So it starts from the consumer unit and goes back to the consumer unit. Just as you can see here, we have this circuit starting from this point here, goes all the way to the first socket, second socket, third socket, and then just like a ring or a loop, it goes back to the consumer unit where it comes from. All right. So that is very important for us to take note of that. Already I have top bosses on the stream. Thank you so much. 9 of us already watching this stream. Thank you so much. And I definitely have Emmanuel Futu says, good job. Thank you so much, Emmanuel, for that feedback. I also have my top boss, Ganyo. Ganyo is saying, my top boss, love. Yeah, sending me a lot of love all the way from Nigeria. Thank you. Sorry, from Ghana. Ganyo, Pios. Is it the correct pronunciation? All the way from Ghana. Thank you so much, Ganyo, with all the love that you are showing me on today's live stream. Now, my top boss, let us talk about this. When we talk about electrical installation, there are many faults that occur, especially when we are wiring a consumer unit. Now, in my consumer unit, I have wired the SPD, the DP-MCB, the RCCB, and the MCCB, and the MCBs, sorry. Now, one thing that I want us to talk about is the cables. Now, when we talk about cables, there are several things that I would want us to talk about. We must talk about the types of cables. We have the stranded, the stranded cables have a lot of wires inside. And we also have the cable which is not stranded, it is just a single cable. As we can see here, I don't know whether from my camera you can be able to see. So what I have is stranded. So this one is basically stranded. There are many wires inside, but this one is a single cable, or what we normally refer to as a single core. DJ Stanza says, top height, love you. Thank you so much. DJ, the mix master, is in the building. Mm. Thank you so much for that feedback. So this one is single stranded, this one is multi-stranded, or it has a lot of strands. Thank you so much for joining in. Smash that like button if, my top boss, you are ready to get some value, or you have already started getting value out of our today's live stream. So when we talk about this stranded cable, we also have this single strand. There are a lot of factors that come into play on the choice that you'll make when it comes to the cables. Application, where are you using these cables? Now, my top boss, another thing that is very important for us to consider is the size of the cable. Why am I talking about these things? It's because most of the hazards that occur in the home, number one, wrong choice of the size of the cable. All right. So if you choose the wrong size, it means that there will be a lot of issues. Number one consideration when it comes to wiring, we are definitely talking about resistance. That is a key factor. Now, from this main source here, where we have this important part here, assuming that this one is my meter box. I have a meter box here. Now let me just ensure that I have everything in order here. Allow me to have the cable clips so that we are able to clip that bit there. Now my top boss, today we are having such a great and wonderful moment together with you because of our topic of the day. If you are able to hack this, if you're able to hack the electrical installation, especially when we talk about the cables, you will definitely sort out a lot of problems. You will not have issues when it comes to electrical installation. Now, from this here, we have a meter at this particular point. Now, from the meter, we definitely go to what we refer to as the consumer unit. The size of the cable that we use for that purpose is what, my top boss? Let me know, what is the size of the cable from the meter box all the way to the consumer unit? Remember, we normally have 1.5, we have 1.0, 1.5, 2.5, 4.0, 6.0, 10.0. We also have 16 mm square. This is the cross-sectional area, of that cable. So let me know, what is the size of the cable that is used from the meter box all the way to the consumer unit? Let me see my top bosses who are aware of that. If at all you are advanced when it comes to electrical installation, if at all you are a pro, do you know the size? I want us to flow together because I don't want to be dealing with people who are top bosses and yet they lag behind when it comes to matters of quality electrical works. Now, from the meter box, my top boss, what is the size of the cable that we use? I already see a lot of you very active on our stream, and thank you so much, my top boss. I can see Titus. Titus is here very much in the stream, and Titus is saying, my top boss watching live from Meru. Salute to you, my top boss Titus. Thank you so much for joining in. And I also have my top boss, Joyful Blue Bonnet. Flowers, great job. Thank you so much, Joyful. Gunyo says, please, I have seen that you have used 2.5 mm cable for lighting system. Please, is it correct job? For the lights, you use 1.0 or 1.5 depending on the load. 2.5 is used for socket installation. Nicholas, good to see you, says, watching from Nairobi. Good work. Thank you. I have a lot of top bosses here in Kenya, my country, Kenya. I'm proud to be a Kenyan. And my top bosses really, really support me. And also, when we meet one-on-one on the road, they say hi, and I'm so grateful because of that. Now, I also have another top boss is saying 10 mm, that is in regards to between the meter box as well as the consumer unit. What is the size? That is the question that I've asked. That you connect from the meter box all the way to the consumer unit. 10 mm, that is from our top boss, Ganyo. I also have Castro Fidel says 6 mm. I also have Kamadi says watching from Nairobi. I can see a lot of love definitely coming in, streaming in all the way from my good country, Kenya. Thank you so much, my top boss. Let me have your feedback real time. How what do you think about my content? So electrical hazards that occur, especially in any electrical installation, we normally have loose connection. That one goes without saying. Loose connections may come all the way from the meter box as well as the consumer unit. So if at all the consumer unit, you have wired and then there are a lot of loose connections there, is going to be a huge problem. Now you may wonder, why is my consumer unit looking like this? Cables everywhere. Why are cables, just scattered everywhere? What I did, I was wiring these connection here, and like you saw my top bus, I introduced a lady. We have a lady that is so proactive when it comes to matters of electrical, and we were wiring this consumer unit, especially from the meter, I mean from the socket, sorry. And so what we did is that we left our cables like that, and we agreed that it is important to have, to make use of this space that is in the consumer unit. So instead of just cutting the cables, people are fond of cutting cables. You just cut the cables because they have reached where they were supposed to be connected, and then you cut them. That is very wrong, top boss. Why? Because in future, assuming that you want to use, you want to reduce the size of the cable, or you are cutting the cable due to a loose connection that has occurred, uh, so that to give room to more cables, to a good connection in either the MCB or probably any connection, maybe it's in the switch or wherever, you must ensure that you leave a lot of room here for the cables. That is something that we definitely agreed, and we say that you don't just cut the cable once it is in the switch or in the consumer unit. You leave room, and enough room for that matter, all right, so that for future repairs everything will be all right with you. Now, when I was a beginner electrical technician, a friend of mine told me that when wiring a consumer unit or undertaking any electrical installation, assume that you will not be the one who will be called upon to carry out maintenance work the next time that this customer wants that work to be done. All right. So you work as if you will not be the one to come back to do that maintenance work. So when it comes to that, we ensure that you even color code. For instance, if you are working and you have run short of this cable, this is a red cable. A red cable is a color code for a live connection or a phase connection. I don't know in your country, what color do you use for a phase connection? All right. When it comes to the neutral we use black. That one is in Kenya, we use black. Now when it comes to earthing, we use green with yellow stripes or yellow with green stripes. So that one is in my country. Patrick Kipngetich says from the meter box all the way to the consumer unit, use a 16 mm square cable. Patrick, thank you so much for joining in. I also have Bam, the electrician. Good to see you, my top boss. You say that you are watching from Riat, Kisumu County. Nice work, my top boss. Thank you so much, my top boss, Bam, for joining in. It means a lot to me when I see Fidel Castro says, wow, long awaited video. I got it, top boss. Congrats. Thank you so much, Fidel. Wow, what a wonderful name. Powerful people, great people have great names such as those. Now, if you have just joined in and you have heard us talk about 16 mm, this is what we are talking about. This is a drop cable. The size of the drop cable or the wire, the diameter, the cross-sectional area is 16 mm square. all right, 16 mm. So whenever you talk about the size of the cable, you are not talking about the measurement of including the insulation. We don't include the insulation, we just include the wire inside. That is what we talk about. So that is very important. So how a 16 mm cable looks like, and this one is specifically a drop cable, from the pole, the utility pole that is supplying the customer with power. So you have this section here, which is definitely the connection to the neutral or a return path for electricity. What is the electricity? Or what is electricity? The flow of current. What is current? Current is the flow of electrons from one point to another in a conductor. Okay? It has to be confined in a conductor. Otherwise, if it is outside there, you don't refer to that as no current or electrons. The electrons have to flow in a direction. Now, again, another thing that we need to talk about is that electrons which are flowing in a circuit form current. All right, so we have defined current. Now, what is voltage? Voltage is the force that pushes the electrons from one point to another, creating another important thing when it comes to electricity, PD, potential difference. So for electrons to move from one point to another, they require a potential difference for them to move in a circuit or to flow. Oh, we use flow. We don't say move, we use flow. So assuming we have a loop like this one, so assuming this is the source, I don't know whether it is visible. So electrons flow from here all the way to here, forming that loop. If at all there is no potential difference, these electrons will not be moved or they will not flow. What is the potential? I mean, what is the force that causes that motion? It is PD, potential difference, or it is the voltage. The voltage creates that difference. So the voltage is like a pump. It pushes the electrons to flow through that loop. We are calling it a loop because electricity has to flow in a circuit, in what we normally refer to as to complete the circuit. So if at all this is the source, which is the transformer here, it will flow from the source. Now it will flow through a live or a phase conductor, and then it will flow back through the neutron, forming a loop. In fact, let us just go ahead and try and come up with something that will easily demonstrate that. So if at all I have this cable here, I don't know if I have another piece for neutral. Yes, I have it. So let me not cut so that we can use it. Can use what we have instead of destroying or wasting more cables. So assuming I have the neutral, and then I have this, which is a phase. So this is my source, and then this is the appliance. Now this is a loop, right? So this upper hand, let it be the transformer or the source, or let it be the battery. In fact, for me to make things easier, let me just do this. So my upper hand, or this hand here, my left hand, let it be the transformer, the source. And then this one, the lower hand, or my right hand, let it be the appliance. For this appliance to operate, it requires the complete circuit. So from the transformer, the charges will flow, the electrons will flow in this direction. But for this appliance to work efficiently, there has to be a return path to the source. So the return path is the neutral, the black cable. So that ring definitely is what we normally refer to as a circuit, a complete circuit. So the electrons will flow in that direction. Now, Why do we have the MCBs here, the switches and so on and so forth? You know, back in the days, probably they would just connect like that, the source, the path for electrons, and then you connect your appliance or your device or your gadget, for instance, a bulb, and then you complete the circuit and that's it. Why was it necessary to include all these devices in the circuit? So this is just like cutting this part here, including an MCB. You cut this part here, you include a switch. You cut this part here, you include a meter, an energy meter, so that you know the consumption can be monitored, the consumption can be billed. Thanks so much for the likes. I see the love from you. I really do appreciate. I also have Amzeru says, I have only the knowledge about single phase installation, but I need to learn more about the